These problems are from section 8.3, which have to do with geometric sequences. So the first one I'm going to look at is number 7. On number 7, they give you the sequence of 3, 6, 12, and 24. And you're asked to determine if it is a geometric sequence and what the common ratio is. If it's a geometric sequence, you're going to be able to multiply each term by an amount to get the next term. So from here, you can take 3 times 2, that equals 6. 6 times 2 equals 12, etc. So this is a geometric sequence. And the common ratio, or R, will equal 2. Let's look at number 9. On number 9, they give you the sequence of 1, 5, 10, and 20. Again, you have to be able to multiply by a common ratio or the same amount. So from here, 1 times 5 does equal 5, but 5 times 2 would equal 10, and 10 times 2 would equal 20. So this is not a common amount here, so there is no common ratio, so it is not geometric. The next problem I'm going to look at is number 27. So on number 27, they ask you to find the general term, or the equation basically, to calculate any term in the sequence. So on 27, they give you a sequence of 2, 10, 50, 250, and then it keeps going, which is what the dot, dot, dot means. So on here, you want to determine what the common ratio is. So here you can multiply each of these terms times 5 to get the next term. So R, the common ratio, is 5. A subscript 1 is the first term, and that'll be used in the equation. So the way to find any term in the sequence, or the general term, is by using this formula. A subscript n equals A subscript 1 times R to the n minus 1 power. So if you substitute in, A subscript n is the way to find any term in the sequence, will equal A subscript 1, which is 2, times R, which is 5, to the n minus 1 power. And that would be the equation. The next one I'm going to look at is number 35. So on number 35, it asks you to find A subscript 7. It gives you the first term, A subscript 1 equals 5, and R, or the common ratio, equals 2. So to find the seventh term, we're going to substitute into A subscript n equals A subscript 1 times R to the n minus 1. And we are going to find the seventh term. So A subscript 7, or the seventh term, you're going to use 5 for A subscript 1 times 2 raised to the, again, the n term here, or n is 7, 7 minus 1. So when you do the math there, the seventh term, or A subscript 7, will equal 320. The next one I'm going to look at is number 45. On number 45, you're given a sequence of 5, 10, 20, and it stops at 5,120, and it asks you to find how many terms in the sequence. So we are going to solve for n. So when solving for n, we're going to use this general equation again. And we're going to substitute everything in and solve for n. So on here, this is A subscript 1 is 5. The common ratio, or R, is 2, because you can multiply by 2 to get these first terms in the sequence. So R equals 2. This is our last term, so I'm going to use this as our A subscript n. So A subscript n, I'm going to replace with 5,120. A subscript 1 is 5 times 2 raised to the n minus 1 power. I'm solving for n, so I'm going to divide each side by 5, which equals 1024. And that equals 2 to the subscript n minus 1 power. You could rewrite them as a base of 2, or you can take the log of each side. I'm going to go ahead and take the log of each side. So the log of 1024 equals the log of 2 raised to the n minus 1 power. I'm going to pull the power out in front. So the log of 1024 equals n minus 1 times the log of 2. I'm going to divide each side by the log of 2. So log of 1024 divided by the log of 2 actually equals 10. So this is equivalent to 10 right here. So we can say 10 equals n minus 1. And when you add 1 to each side, n would equal 11, which means there are 11 terms in the sequence.